Good evening, class. We are looking at college algebra, the foundation for that, the basics that we need to be comfortable with to get us started. Natural numbers. I'm just refreshing your memory about natural numbers, also called counting numbers or positive integers, 1, 2, 3, 4, all the way to infinity. That's one set of numbers. Of course, 3 does that, means it continues indefinitely. Whole numbers, the same thing. We also have 0 there. Natural numbers and 0. Integers, whole numbers and the opposite or negative of every natural numbers. So not only we have those, we also go to the left on the negative side. Rational number. Any real number that can be expressed in the form of a over b, where a and b are both integers, and that's really the key. The top and the bottom must be both integers. That's called a rational number. That's a definition of a rational number. Irrational number, any number that is not rational, meaning numbers like square root of 2, cube root of 4, pi. Now, as far as rational versus irrational, there are also decimal numbers, terminating decimals. I want to write those. So terminating decimals such as, for example, 2.1 or 0.5, or repeating decimals such as 0.3 bar. Those are also considered rational numbers. But when you look at the concept of irrational number, if you put it into a calculator, it continues indefinitely and you have to just truncate it, okay? You have to round it. For example, pi, it's not equal to 3.14. What is it equal to? 3.1415, and it continues indefinitely. When we put rational and irrational numbers together, we get a set of numbers. Their union is called, the set of numbers is called real numbers. So this is just to refresh everyone's memory. All right. Absolute value. Basically, absolute value is defined as distance from 0. As a result, the absolute value for any number is either positive or 0. Example, if you look at 5 or negative 5, both of them have the same distance, namely 5 units from 0 on a number line. And so the absolute value of 5 is 5. The absolute value of negative 5 is 5. What I want to write here, I want to write a general format here for everybody. You may have seen this. X, if x is larger than or equal to 0, minus x, if x is less than 0. So when you're looking at this one, this is the top part. This one is the bottom part. And it is extremely important to understand the meaning of it. It means if what's in there is negative, you're going to write the opposite of that. So in essence, to write this, you really have to write the opposite of that, meaning you should write minus -5, which is +5. And the reason I mention it, because if you're dealing with variables, it does make a huge difference, understanding the concept. All right, let's review the exponents and polynomials. A and B are not 0. A to the power of 0 is 1. This is the 0 exponential rule. A to the power of m times a to the power of n is a to the power of m plus n, meaning this is the product rule. A to the power of m to the power of n is a to the power of m times n. This is the power rule. And then a times b to the power of m, each one gets powered up by m. So that's a combination of the power point, if you will, with the product rule. So a to the power of m over a to the power of n, this is the quotient rule, a to the power of m minus n. And if you have a over b to the power of n, that means each one gets powered up, the numerator as well as the denominator. A to the power of minus n, this is a negative exponential rule. There are different types of them, and we're going to discuss 1 over a to the power of n. If you have a negative exponent at the bottom, you bring it up. If you have a parenthesis to the power of negative, flip it over to the power of positive. All of those are negative exponential rules. Therefore, if this is the case, what is this equal to? 1. What is this equal to? 1. What is this equal to? Can we distinguish between the two? This one, order of operation, 4 to the power of 0 is 1, but the negative sign remains, and that's the key, order of operations. And I mentioned that because I want to make sure that you distinguish between the two. So next to each other, it makes more sense to look at it this way. All right, we're going to find the following products. For example, this one. And all you have to do when you want to come up with the answer, use this rule, add 4 and 7, 4 and 7, and it becomes y to the power of 11. For this one, of course, you can do it in one shot, but one way is to put the numbers next to each other, 6 times 9 times 2, and the rest of them together. Again, you don't have to write that step, especially for a college algebra student, but it is up to you. If you do that, and let me just put a parenthesis here, then you multiply these three numbers. 6 times 9 times 2 is 108. That's 54 times 2, 108. And then z to the power of, you use this product rule, 5 plus 3 plus 2, which makes it 10. So 108, z to the power of 10. All right, there are power rules that we discussed. So let's go over them with one example. 5 cubed to the second power. 5 cubed to the second power. 2 times 3 makes it 6. So 5 to the power of 6. Okay, the order is not fine here. Give me a quick second. All right, class. So we want to use the rules that were mentioned. So in this case, simply put 5 to the power of 3 times 2, or 5 to the power of 6. That's the purpose of that. This one, each one gets powered up by 3. So 3 to the power of 4 to the power of 3 and x squared to the power of 3. Needless to say, you can do it in one shot. So these two give us 3 to the power of 12. These two, x to the power of 6. Very straightforward. We're going to apply the 3 to each one, the numerator as well as the denominator as a power. Therefore, this is 2 to the power of 5 times 3 or 15. This is b to the power of 4 times 3 or 12. Needless to say, the denominator can't be 0. Like terms are terms with the same variables raised to the same powers. In other words, if you drop their coefficient, they are identical. So I hope you realize here's the coefficient for this one, here's the coefficient for this one, and this one means -1. So without the coefficients, they must be identical. A polynomial is a term or a finite sum of terms with only non-negative integer exponents permitted on the variables. So we can add up like terms. So in this case, these two are like terms because they have y to the power of 4 in both cases. These two are like terms. So -3 and 7, 4 y squared. And finally, these two are like terms, y and 6y, they add up to 7y. Now, whether you want to write this step or you want to skip it, it's obviously up to you. This is your final answer. Using FOIL to multiply two binomials. I hope you remember the concept of foiling. F stands for the firsts, this one and this one. O stands for the outers, this one and this one. I stands for the inners, this one and this one. And L is the lasts. So that's how we're going to do it. So by now, of course, you have seen this many, many times. You can probably even do it in your head. It is important to be able to do this actually in one shot and come up with the answer. 6m times 4m is 24m squared. 1 and -3 is -3. So what you do, you multiply these two, and you multiply these two, and you add them up. This will give you 4m, and this will give you -18m, and this will be your middle term. The reason it's important we be able to do that, so the reverse process. So we can do the factoring. All right, these are some of important multiplications that we should be comfortable with. For example, x plus y squared. Sometimes you see it as a plus b squared, a minus b squared is the same thing. And so when you want to come up with that, all you have to do, remember that you square the first one, and then 2 times the first times the last, 2xy, and then y squared. This one, you square this one, then minus 2 times the first times the last, and then y squared. This right side is called perfect square trinomial. perfect square trinomials. And of course, x plus y times x minus y is x squared minus y squared, the difference of squares. We need to remember those formulas to be able to move on. All right, the reverse process of multiplication, as you recall, it's factoring. So in this case, if you want to factor, all you have to do factor the y squared. Now, of course, you can take the y squared from this one and it becomes 9y cubed, and this becomes y squared times 1, and therefore it's y squared times 9y cubed plus 1. I would go from here to here. I think at this level we should be able to just see the answer in one shot. Anytime we have more than 3 terms, we have to do it by grouping. And I'm going to explain that in the next page. I just wanted you to see an example of that. So we're going to put these two together. We're going to put these two together. It may or may not work. If it works, fine. If not, then we put these two together. If not, we put these two together and these two. So you have to try all of them until it works out. So if you put the first two together and the last two, do we have anything in common here? Do we have anything in common here? And when we take it out, the parentheses that is generated, are they identical? Let's find out. So in this case, we can clearly see that m is in common. So we get p squared plus 7. In this case, clearly number 3 is in common, and we get the same thing, p squared plus 7. And that's really the key. What you really need to see, that these two are identical. So basically you would write that, and whatever is left from here, it's m, that's the second parentheses, and whatever it is here, plus 3. That's how you do the factor by grouping. And I'm sure everybody remembers them. Now, let's look at the synopsis of the factoring. First and foremost, I'm just reminding everybody about the exponential rules that we mentioned. Secondly, let's start from the top. What is the very first step, everybody? GCF. The greatest common factor. Your first step in factoring is to take the GCF out. Number 2, look at the number of terms. How many do we have? 4 or more. We have to do it by grouping. If we have 3 terms, then is it a perfect square trinomial, such as a squared plus 2ab plus b squared, which becomes a plus b squared? Or a squared minus 2ab plus b squared, which becomes a minus b squared? If it's not a perfect square, then it's in the form of x squared plus bx plus c, where a is 1. We want 2 factors. The sum must be b and the product must be c. So we come up with 2 factors of c, and that must be the case. So x plus the first one, x plus the second. And if a is not equal to 1, you have to use the trial and error, or find 2 factors of AC. Now this time, if we go back here, we want 2 factors of C, whose sum is B. Now you find 2 factors of A times C, whose sum is B. Write these factors as coefficients of 2 like terms that when combined equal Bx, and then factor by grouping. Again, I'm giving you the synopsis of the factoring. I know you all remember that, and you're in good shape, but in any event. So a difference of squares, a squared minus, and number 5, if we have 2 terms, what happens with 2 terms? Either we can't do it, and remember, we've already taken out the GCF, that is our first step. So after that one is done, either we have a difference of squares, a squared minus b squared is a plus b times a minus b, Or sum of cubes, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Or a difference of cubes, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Or it can't be done. And needless to say, how do you check your work? Multiplication. That is the reverse process. So you check with multiplication. Okay, everybody? All right. So we said these are called perfect square trinomials. And here's the examples we want to look at. Okay, so this is the general idea. So this is the one that we want to factor. Those are special products. Notice this is a 4p squared. This is the perfect square of 4p. This is 5q squared. So it's a perfect square of 5q. What is this? Is this the product of those two times 2 or times -2? It's times -2. So please understand, this is a perfect square trinomial. This is a perfect square trinomial. Is this the product of these two times either 2 or -2? It is times -2. Therefore, because of this, it follows this one. So 4p minus 5q quantity squared. This one is a perfect square of 13x. This one is a perfect square of 4y squared. Is this the product of those two times either 2 or -2? By the way, this clearly says minus, this clearly says plus. So it's probably +2. Let's find out. So you write this part and you write this part, and then you work it out. If I multiply 13x by 4y squared by, since this is positive, by +2, do I get this? So you really have to see that this must be equal to this, in which case you are going to use this one, x plus y quantity squared. So 13x plus 4y squared quantity squared. That's how you use that perfect square trinomial. The next factoring, which is a special product that was discussed, is the difference of squares. X squared minus y squared is x plus y times x minus y. And as we look at this, we notice this is 2m to the second power minus 3 to the second power. And now this follows the difference of squares. So 2m plus 3, 2m minus 3. In any order, you can write these parentheses first. Now, a couple of things I want to mention. After you take the GCF out, if one of them is a perfect square, the other one is not, we can't factor it. In this case, when we get this one is a perfect square, this one is a perfect square, but this is not the product of these two times 2. If it's times any other number, then it can't be done. For example, we don't have a 2, or for example, we don't have a -2 here. So it can't be factored out. Difference and sum of cubes. I hope you remember x cubed minus y cubed is x minus y times x squared plus xy plus y squared. Notice there is no 2 here. So this is a prime polynomial. Let me write it down. This, or this one are called prime poly, short for polynomial. Okay, so this is x minus y times x squared plus xy plus y squared. This is x plus y times x squared minus xy plus y squared. Couple of things I want to mention. Both of them have one negative sign here. This one in the first parenthesis, this one in the second parenthesis. Number one. Number two, I mix up. I am not too sure. I forgot. So how do I come up with the correct answer? Check. multiply these two, you get to. So if you have any doubts whether you need a sign here or here, negative sign, so just multiply them through and see if you can come up with the answer. So in this case, obviously, x cubed, clear, 27 is 3 cubed. And therefore, we are going to follow this. So we're going to write x plus y, that means x plus 3, then x squared minus xy minus x times 3 or 3 times x, plus y squared or 3 squared. And of course, the 3 squared is 9. And as I mentioned, anytime you have doubts, you've done the work, you're not too sure, just multiplying through, and it should work out. Okay, class? Lowest terms of a rational expression, fundamental principle of fractions. As you know, anytime you have a fraction, you want to make sure you put it in its lowest term. For the sake of argument, you can never say this is my final answer unless you're raising a fraction. The final answer is 1/2. And that's the idea behind this concept. So with that being the case, if we are given this rational expression, in order to put it in lowest term, and we don't know, it may already be in the lowest term, we do factoring. So it's 2p squared plus 7p minus 4. First, I want you to know that it's really not too bad because 2 is a prime number. And so it's just 2, and you need a 1. And then 4, of course, negative. You have to go with 1 and 4, or 2 and 2. All right. And I hope you realize the reason you can't go with 2, because if you went with 2, I want to show you something. I hope everybody's following. So 2, that's not a good color. So you need 2p and you need a p. Now, number 4, I can go with 1 times 4 or I can go with 2 times 2. If I put 2 and 2 and one of them is negative, I got to figure out which one. The reason it doesn't work, so right here, there is a common factor of 2. So that doesn't make sense. It has to be 1 and 4. But where do you put them? All you have to do, look at, let me clean up the mess. All you have to do, look at the middle term. What is this? Minus p. What is this? 8p. They add up to positive 7p. And the bottom is 5p times p plus 4. Because simply put, you take the 5p out, and the common factor of p plus 4 cancel each other, 2p minus 1 over 5p. So that's factoring and simplifying. How do we multiply fractions in general? Well, or rational expressions. You multiply the top, you multiply the bottom. How do you divide? You flip over the second fraction, the divisor. And so this is a multiplication. You can multiply it right just the way it is, or start simplifying first. What you can do, class, you can start simplifying here. For example, 2 goes away. So let me show you both ways. So I can say 2 goes away and 8 becomes 4. I can say y goes away and this becomes y cubed. It's a different color. Let's see. I can say 9 goes away and this becomes 3, as long as you pick one from the top, one from the bottom. So what do you have in the numerator? You have nothing except number 3. So I hope you see the top is only 3. What is the bottom? 4y cubed, and that's your final answer. Or you can write them in the following manner. So 2 and then 27, because you see 9 here, write it as 9 times 3. The bottom is 9. Because you have 2 here, put the 8 as 2 times 4. And then because you have y squared at the top, put the y to the power of 5 as y squared times y cubed. This way, you can get to the answer. Do you want to do that or not? I guess as a college student, college algebra student, you should have no problem doing it just the way I did it, fairly nice and easy. All right, we want to do this division, which means we are going to factor this, and we're going to factor this, and we're going to flip over the second one. So again, believe it or not, this is not difficult because number 3 class is a prime number, so you have no choice but to go with 1 and 3. And then again with number -4, go with 1 and 4, or 2 and 2, one of them negative because this is negative. All right, that's the first one. This one, 24p cubed minus 8p squared. Obviously, 8p squared is in common. This one, you put it in the denominator, 9 is in common. This one, you put it at top, 12, because between 24 and 36, 12 is in common. P cubed, 12, p cubed. So this one is p plus 4 times 3p minus 1. This one, take a common factor of 8p squared. This one, take it down. Let me just do this. This one, we are taking it down here. I haven't done it. Oh, I'm sorry. I haven't done it yet because I still kept the division. Well, we'll flip it. We have to flip it over. So this one stays at top for now because I haven't changed the sign yet. So 9p plus 36. And then this one, 12p cubed times 2p minus 3. Now it's time to flip this over and change this to a multiplication. So this comes up, this goes down. And so p plus 4 cancels out p plus 4. Three p minus 1 cancels out 3p minus 1. We can do more canceling, but let's write them so it doesn't get crazy. So what is left from the top is 12p cubed times 2p minus 3. From the bottom is 8p squared. And so we can do the cancellation here. As you can see, I can get rid of the p squared here completely. And this becomes p. And then 9 times 8 is 72. 12 and 72 cancel each other because 72 is 12 times 6. And that's what we get here. And this is our final answer. This is our final answer, everybody. All right. Simplification. When you want to add or subtract rational expressions or fractions, you need to come up with the LCD, the least common denominator. And to come up with the LCD, in the case of irrational expressions, we should be able to factor. So what is the LCD? The way it is, we don't know. So we are going to factor this denominator into y times y minus 1. And this one first, I'm going to take the GCF out, namely 2. And of course, y squared minus 2y plus 1 is y minus 1 squared. All right. Now I need the LCD. So let me write the LCD here. LCD, the least common denominator. Well, we need number. So let me just. So we need number 2. We need y, and we need y minus 1. This has exponent 1 when we don't write it. This has exponent 2. If we write it with exponent 2, it covers everything. So the LCD is 2y times y minus 1 quantity squared. That's the LCD. Now we're going to raise each fraction such that this is our common denominator. So when we want to raise it, here's how we do that. We take a look at this denominator and we take a look at this LCD and what is missing here. In other words, you want to divide this one by this one. So what is missing here? Number 2 is missing. What is missing here? Y minus 1 is there, but it has a square here. That means y minus 1 times y minus 1. So this one is missing 2 times y minus 1. This one, 2 is there. Y minus 1 squared is there. So what is missing? Just the y. So we raise each one accordingly. So again, you have to multiply. Please understand, this part is in essence equal to 1. You are raising the fraction, you multiply the top and the bottom by the same factor here and here. Now they have the same denominator. Now, we can take a couple of steps or more or less. I hope you realize that if you just keep the 2y plus 2 times y minus 1, we can see that it's y squared plus y minus 2. So just, we can write that. And the denominator, for both of them, we can write the least common denominator. Okay, we can write the least common denominator. Again, do you have to take all those steps or not? It's up to you. So again, we multiplied this y plus 2 by y minus 1 gave us this. So what we have now, we have the LCD and then 2y squared plus 2y minus 4 minus this negative minus 3y squared. So we wrote it here. And this one and this one will combine into negative y squared. By the way, you can always take the negative out, because if you wanted to factor, if it's possible to factor it, and observe whether you can do it or not, okay? All right, simplifying complex fraction. Let me do this. So this is the main fraction bar. Okay, everybody, this is the main fraction bar. So what is a complex fraction? A fraction within a fraction. You notice we have a fraction, and then at top we have a fraction. You can have even one fraction and it makes it a complex fraction. Or you can have more than one. It doesn't matter. We have a complex fraction as a result. So what do? We multiply the top and the bottom by LCD. What is the LCD? A times A plus 1. I hope you see that. When I say LCD, you look at 1, 2, 3, 4 fractions. So you multiply by the LCD for all 4. You multiply by LCD for all 4 fractions, which is A times A plus 1. So what happens when you do that? I'll show you the next step. I'm not too crazy about the next step and writing it. Just you write multiplication of this by this, this by this, this by this, this by this. You could see, I mean, this is extra step because right here, if you multiply these two, A plus 1 goes away, you get A times A, which is A squared. If you multiply these two, A goes away 1 times A plus 1. If you multiply these two, A goes away 1 times A plus 1. If you multiply these two, A plus 1 goes away 1 times A. Or just do it here if it's easier. So A squared plus A plus 1, A plus 1 plus A. Obviously, the denominator, we can combine these two into 2A, and there is nothing else we can do. And this can't be factored out. All right. Let's look at negative exponent. We've done it already. If A is a non-zero real number and n is any integer, then we know a to the power of minus n is 1 over a to the power of n. And as far as this one is concerned, we flip this over. Remember that 2 over 5, if we go with this one, becomes 5 over 2 and to the power of positive 3. So 5 over 2 cubed, 5 halves cubed. So cube this one, 125, cube this one, 8, and you're done. Rational exponents, the nth root of a is a to the power of 1 over n for all integers m, all positive integers n, and all real numbers a, for which a to the power of 1 over n is a real number. This is the case, and this is the case. A to the power of m over n is a to the power of 1 over n to the power of m. Also, this you can write it as nth root of a to the power of m. You can also write it as the nth root of a to the power of m. So these are various ways of writing. So in this case, if we want to stick with the rational exponent, we can write this as 125 to the power of 1/3 to the second power. And the reason we do that, because this one, we recognize it as cube root of 125, which is 5, and square it becomes 25. Now, to simplify this, you can do this in one shot, everybody. Meaning, since the base is 27, you can say 27 to the power of 1/3 plus 5/3 minus 3. Let me write that. You can do it that way. You can write this 27 to the power of 1/3 plus 5/3 minus 2, or combine the top first. Obviously, 1/3 and 5/3 would be 2. And then 2 minus 3 becomes -1. And 27 to the power of -1 is 1 over 27. So exponents Fourth root of 16, you should know the answer is 2, of course. But if we go to look at it from a different point of view, from a rational exponent point of view, that means 16 to the power of 1/4. As you know, 16 is 2 to the power of 4. And now 4 times 1/4 makes it 1. I would say you should know the answer is 2. For the next one, again, you may recognize that negative 32 is negative 2 to the power of 5. And their product is 1. So the answer is negative 2. That's something that I guess everybody knows. All right, so we're going to continue with notations for radical as well as rational exponents. So a to the power of m over n is the nth root of a to the power of m, or the nth root of a to the power of m. And here's an example. So a to the power of 2/3. We're going to write this as a cube root because the denominator is 3 cube root of 8 to the second power. Now, we don't want to raise this to the second power first. First, we want to take the cube root, make it smaller. So it becomes 2, square it, and it becomes 4. Negative 32 to the power of 4/5. Well, this means the 5th root of negative 32 and then raise it to the power of 4. The 5th root of minus 32, we should know it's negative 2. We've discussed that already. Negative 2 to the power of 4 is positive 16. All right. Evaluating this expression, if n is an even positive integer, then it's the absolute value of a. If n is an odd positive integer, then it's equal to a. So, for example, this one, when we divide 4 by 4, we get 1. So it's the absolute value of p. The reason we say an absolute value of p, because we don't know if p is positive or negative. That is extremely important. Bear in mind, regardless of what p is, when you raise it to the power of even, it becomes positive, and the 4th root of positive is positive, okay, because the index is even. So since we don't know, we put it in an absolute value. If they mention that the variables represent positive values, you don't need it. In this case, since we are taking the root, square root, this is 4 squared, this is m to the power of 4 squared, and this is r cubed squared. Or I'll show you the second method quickly in a minute. If we knew that the variables represent positive, we would just say 4m to the power of 4 r cubed, because this is true. And remember, whenever we don't write the index, you know, when we don't write the index is 2. This is called the index. And so 4m to the power of 4 r cubed. But because we don't know, this is fine. It's a number, is positive. This is the power of even, is positive. But this one is odd. We put that one in an absolute value. So you put the whole thing in an absolute value. This can come out. This can come out. This one is like that. Now, if we know it represents a positive, then the idea is that 16 gives you 4. And this one, you divide 8 by 2. You get 4, you divide 6 by 2, you get 3. So you divide by the index. So when you divide by the index, you get 1. But why is it important to write absolute value? Because when you raise to the power of 6, it becomes positive, since 6 is an even exponent, and therefore the answer is not -2, rather positive. And that's something that sometimes students make a mistake. We want to make sure this is taken care of. All right, rules for radicals. When we want to multiply them, if they have the same index, we can multiply the inside. Or if you want to divide them, the same thing. By the way, we may go from left to right or right to left, the same thing here. And in this case, you multiply the two indices, m times n, so the new index is mn. So if I want to multiply these two, I can do that. And it becomes 6 times 54, which is 324, and the square root is 8. It's the square root of 324 is 18. But even if the number is large and we don't want to go that route, can we do it by factoring? So I want to show you a different method, how you come up with the answer by factoring. So you're going to write number 6 as 2 times 3. 54 is a different color. 54. Can you divide by 2? Yes, you get 27. By the way, 27, you may know is 3 cubed, so you can do it 3 times. So it's 2 times 3 cubed. So what you're looking at is the square root of 2 squared. This is 3 cubed, I said. No. Times 3 to the power of 4. And so, everybody, 2 squared comes out as 2. 3 to the power of 4 comes out as 3 squared, which is 9. 2 times 9 is 8. You can do that. All right. What about this one? We have m cubed. If you multiply these two, and it comes out as m. Because it's a cube root, it's always positive. Okay? Since the index is odd, we don't have to worry about anything. Whatever is in there comes out. If it's negative, negative comes out. If it's positive, positive comes out. In other words, I want to make sure we understand that cube root of 8 is 2. Cube root of -8 is -2. Okay? That's what I'm referring to. All right, 7 over 64. We want to take a root of that. You can separate them into square root of 7 over square root of 64, because you know square root of 64 is 8, and you're done. If you're going to simplify this, there are 2 ways. One is to see the big picture. It's the product of 25 and 7. $25 comes out as 5. You can write this step or skip it. It doesn't matter. You can go directly to this. Or you can just write the factored format if you go through the process of factoring. This one, I'm going to show you the method that you've seen in, I don't know, maybe elementary algebra, and I'll show you the method that I want to discuss, which I believe is a lot easier. So if you want to go that route, we know that AD1 is 27 times 3. X to the power of 5 is x cubed times x squared. Y to the power of 7 is y to the power of 6 times y. And we keep the z to the power of 6. The reason we do that, because this is a perfect cube. So is this one. So is this one. So is this one. And we write the rest of them next to each other. So 27 can come out as 3, x cubed as x, y to the power of 6 as y squared. This comes out as z squared, and the rest remain inside. But I'm going to show you how to go from here to here without having to go through this process. All right. So AD1 is 3 to the power of 4. You divide the exponent by the index. So class, if I divide 4 by the index, I get 1 with the remainder 1. So I'm going to put 3 to the power of 1 out, 3 to the power of 1 in. I want to make sure, of course, 3 to the power of 1 is 3. Now, the next one is x to the power of 5. So 5 divided by the index is 1 with the remainder 2. So we get x to the power of 1 out and x to the power of 2 in. Y to the power of 7. 7 divided by the index 3 gives you 2 with the remainder 1. So we get y to the power of 2 out, y to the power of 1 inside the radical. Let me use a different color. Finally, z to the power of 6. 6 divided by 3 is 2. There is no remainder, so it comes out as 2. And therefore, this is a lot faster, class. I'm going to erase this stuff at top here. If I were you, I would take this method. I think it works out better. Add and subtract. Remember, adding and subtracting like terms. In this case, we are adding and subtracting like radicals. So that means anything that is under the radical, if it's identical, you can add them, otherwise you can't. So, for example, right here, we see that 18, we can say 9 times 2. This is 36 times 2. And so 9 comes out as 3. So this is fine. There's nothing we can do to simplify this. 9 comes out as 3. 36 comes out as 6. And so now we multiply these two. We get 24. We multiply these two. Also, we get 24, which means we have minus 24 squared root of 2 plus, use a different color on that, plus 24 squared root of 2, and these two cancel each other. 7 squared root of 2 is the final answer. All right, we want to combine these two the way they are. We can't combine it. So we're going to simplify each case. Remember, when we don't write the index is 2. So 98 is the product of 49 and 2. Why 49? Because we know 49 is 7 squared. And if you don't know that, you just work it out. 98 divided by 2 is 49, divided by 7 is 7, divided by 7 is 1. Therefore, this means 98 equals 2 times 7 squared. You can write it in that fashion. All right. Now, the same thing for number 32. You can work it out as 2 to the power of 5 or 16 times 2. Either way is fine. So what happens next? 49 comes out as 7, 2 remains, x squared comes out as x and y remain. The same thing, 3x is there, 4 comes out, the rest of them remain inside. So again, 49 comes out as 7, x squared comes out as x. And remember what I told you. Here's the way I would approach that. I'm going to divide number 3 by the index, which is 2. And I get 1 with the remainder 1. So 1 comes out, 1 sits in. Okay. And so these two, they give us 12x square root of 2x. What I want you to notice when we put them like that, these two parts, look at this part and this part, they must be identical. So all you have to do, add 7 and 12 as the coefficient, so it becomes 19x square root of 2x. They must be identical. All right, we want to multiply this again using foiling. So we multiply these two, we get square root of 2 times square root of 8. Multiply these two, multiply these two, multiply these two, and we write them in this fashion. Now, this is 16, square root of 16. This is 5 square root of 2 with the negative in front, 3 square root of 8. Now, 8 is 4 times 2, so it's 2 square root of 2. Okay. And as you know, this is 4. So we can combine the 4 and negative 15, we get negative 11. And these 2 square root of 2. And we're done. We want to multiply these two. I hope you recognize this is a minus b times a plus b. So the answer is a squared minus b squared. So we have 7 minus 10 because we square each one and we get negative 3. Using special products is extremely important to be comfortable with. Okay, everybody? Four over square root of 3, we want to rationalize the denominators. If they said rationalize the denominator, or they say divide, it means the same thing. So anytime you have a case like this, you're going to multiply and divide by the square root of 3, the denominator. So I hope you realize this simply comes out as 3 and we are done. Now, this was a square root. What if the index is different, for example, cube root of x? It is extremely important to know you want this to come out. So you can't say I'm going to multiply it by cube root of x. You are going to multiply it by something such that it comes out. For that, you look at the index and you look at the exponent. Let me write the exponent. The exponent obviously is 1. For this to come out, we need the exponent to become 3. So we need x squared. So you multiply by cube root of x squared or it doesn't work. Why x squared? Because the product of these two is x cubed. So cube root of x cubed is x. And the top doesn't change. But please understand this fraction must be 1. And it is. And this is x and it comes out. So it's very important to see what you multiply by. Finally, if we have 1 over 1 minus square root of 2, when the denominator has 2 terms, then you have to multiply by the conjugate. And again, remember the conjugate for a plus b is a minus b. Their product is a squared minus b squared. So the conjugate for 1 minus square root of 2 is 1 plus square root of 2. We multiply the top and the bottom by it because this fraction is equal to 1. So if I multiply these two, nothing happens. I keep 1 plus square root of 2. But if I multiply these two according to this, I get 1 squared, 1 squared minus square root of 2 squared, which is 1 minus 2, which is negative 1. So if you have 1 plus square root of 2 and you're dividing it by -1, you are doing what? You are changing the sign. You get -1 minus square root of 2. And that's all there is to it.